Okay, so as we just covered what is the weakness of the linear probability model, and we're going to dive into logistic regression model. A quick recap. So the main problem for the linear probability regression model that is very similar as what we already seen before is that it can make your probability larger than 1 or go into the negative territory, which does not make sense. So therefore, the best model you can use to predicting the binary outcome actually is the logistic regression. So the logistic regression model is not linear regression model. Okay, so you will see some multiple choice questions or true or false questions in the test that you need to be very clear that the logistic regression model is not linear regression model. Why is that? I'm showing you here. Okay. So the logistic regression model's math is look like this way. P equal to exponential beta 0 plus beta 1 x1 plus beta 2 x2 plus etc. plus beta k as k divided by 1 plus exponential beta 0 plus beta 1 x1 plus beta 2 x2 plus etc. So therefore you can see it is not linear. It is a non-linear regression model. Okay, so the good thing for this structure is that no matter what your x variable going to look like, once you plug in this functional form, your predicted probability always going to be between 0 and 1. It will never over 1 or even go into the negative territory. That is what we are looking for. If we are using a model predicting the probability, it has to be bounded between 0 and 1. So therefore, the logistic regression, the functional form, allow us to achieve that goal. Okay, so keep in mind, this is not a linear regression model. It is a regression model, but not linear. Second, let's look at the connection between this logistic regression with the linear regression model we saw before. So basically, the term inside this exponential, it is our linear regression model we saw. So what we did here is we did this transformation allow us to assure the predicted that y, the dependent variable, is between the range we think is right, 0 and 1. But the way we think about our relationship between x is still the same. So we put it in the linear form within your exponential terms. Beta 0, my y-intercept, plus beta 1, the partial coefficient to the x1, beta 2, the partial coefficient to x2, etc. So if you think certain outcome, the independent variable will have impact on your binary outcomes, that is the model you are building. So you just throw into this form so that you can assure your predicted outcome is between 0 and 1, but the idea is still the same. Okay. So the way we are estimating this model is no longer OLS, ordinary least square. It no longer works because it's nonlinear. So therefore, we're going to use another technique called maximum likelihood estimation. Again, that's when I said the math part become complicated. That will not be the focus for this class. Okay, you just need to know when you need why the logistic regression is doing better than the linear probability regression model. The second is how this logistic regression model look like. So if I give you the output from the software and you are able to predicting the value for p, right? You just literally just plug in this form, right? Exponential. I will show you in the computer skill lectures to show you how you're getting this value p. Okay. The second is how to interpreting those partial coefficient betas. Okay. Anyway, now let's look at the what we did. Okay, so compare linear regression model, linear probability model, which is this blue line. After we do this functional form transformation, instead of this straight line, now the line is a curve. The good thing for this curve is that it's bounded between 0 and 1. That is fitting the requirement for the probability we already learned, the probability theory, right? So therefore, like I said, when you are thinking to predicting any binary outcomes, the best choice is the logistic regression model instead of linear probability regression model. Okay. Now let's revisiting the problem we already seen in the last video. That is using the number of the minutes of people outdoors without a mask to predicting their probability to getting that respiratory illnesses. Here, like I said, I'm going to show you the result directly. We're focusing on how to interpreting the result and how to predicting the result. So first, estimate and interpret the logistic regression model using illnesses as the response variable and minutes as the predictor variable. So again, I'm going to show you the output from the software. Again, Excel cannot do it very easily. So therefore, the result usually coming out from the Python or R. And then we are not learning that part, but at least you know this is the result, the output from the software. You know how to fit them into that equation we just saw, the logistic regression. And the second, predict the respiratory illness probability for an individual who spent an average of 8 hours outdoor without a mask. Okay, same task. So you need to know how to plug in the x value to your equation to get in the probability value. Okay, let's look at the answer together. So first of all, let me show you the result here is coming out of the Python. Okay, so the intercept negative 3.33, and then the slope or the partial coefficient for minute is 0.0056. And so how these two values fit into the logistic regression model, here they go. So you need to remember how this logistic regression model look like. So your dependent variable, the probability of the illnesses, equal to the top is the exponential, the beta 0, negative 338889 plus your 0.055 times the minutes. And then the denominator is 1 plus that. You repeat your numerator again. So that is how you form your logistic regression model, how they look like. Okay, now the second question is, let's plug in my 8 hours. So after I convert 8 hours to minutes, it's equal to 480. I just plug in that value. So that gives me the probability equal to 0.3428. Okay, so you also can try plug in the one we showed in the last video. It doesn't work, which is 1,200. And you will find that the probability here will never over 1. Okay, or even go into negative territory. So that satisfy our needs about the probability. Okay, so as you can see, the differences is not that. If you recall the previous when we use the linear probability regression model, so we predict 38%. Once we change our functional form, the probability very close, 34.28%. Okay. So again, this logistic regression model is way better than the linear probability regression model. The main reason is the logistic regression model will never give you the probability larger than 1 or smaller than 0. Okay, so in our next video, we're going to focus on, hey, given this is the result, how can we figure out the odds? For instance, what is the odds for this person getting illnesses, right? So we're going to look at, given the result from logistic regression, how you figure out the odds.